In January of 2024, researchers discovered a structure in space that is so big it should not exist. This is a story that even made it into the mainstream media, and in general I don't like making videos about this kind of breaking news, because in science it's mostly not a good idea to jump the gun. You always need some more time and more results to really gauge new findings and what they mean and how serious they can be taken. So for the time being, we have to take everything with a actually not so little grain of salt. Anyway, this so-called Big Ring consists of galaxies and galaxy clusters and is about 1.3 billion light years across. It is in fact not a ring, but shaped more like a coil or helix, and only looks like a ring from our perspective. Okay, but what does too big mean? Too big for what? To understand that, we'll have to start with the cosmological principle. In simple words, it says that if you look at the universe at a large enough scale, it looks the same everywhere and in any direction. We call this homogeneous and... I always forget the second one. Homogeneous and isotropic. Or in fancy words, homogeneous and isotropic. Sure, on smaller scales we have planets and stars and galaxies and lots of structures like that. But if you zoom out far enough, the universe looks the same everywhere. So for this to be the case, it follows that there must be some kind of upper limit for how big a connected structure can be in the universe. And if you calculate that, you'll get a result of between 1 and 1.2 billion light years. That is not a hard cutoff, but more a range estimate. So with 1.3 billion light years, the Big Ring isn't actually that far off. It's more of an edge case. Why is it interesting then? Because there are other structures like this we've already found, like the Klaus-Campusano Large Quasar Group, the Huge Large Quasar Group, the Sloan Great Wall, the CFA2 Great Wall, the BOSS Great Wall, the Hercules Corona Borealis Great Wall, etc. Some of which drastically violate the upper size limit for the cosmological principle. However, there is still a lot of debate going on whether these structures actually are structures and how they should be measured, and whether they might be based more on wrong assumptions or wrong biases. Well, to give you a somewhat oversimplified analogy. Suppose you are an alien species observing the Earth from a large distance away. Suppose one of the few things you could measure were the highest peaks of mountains on Earth, which would give you a map like this. Now, does that imply there is a huge structure of mountains all around the Earth? Well, in this case, no. But this approach isn't completely wrong if you look at just subsets of peaks, where this gives really good results actually. So the assumptions that we have huge mountain ranges wherever we have mountain peaks may be wrong, but it may also hold true. Okay, cool. So what now? The point is, we found something potentially interesting. And it's something that should be looked into further. Maybe there is something there. That's all it is at the moment, an indication, a hint. So this whole story might go a number of different ways from here. Maybe we'll never hear of it again. Ever. Or people look more deeply into it and find the correlations to be spurious, basically debunking it. Or we'll find that these structures are all real, and we'll have to find an explanation for them, either within our cosmological models, or we'll have to find a new one. Only time will tell.